Hey guys, let me just get this situated. There's my answer key. All right, so here we go. Chapter 12, Part 1 Study Guide. I feel like I'll just write these in so you can double check them, but you have the diameter. Well, here. Go ahead and check those and you can just make sure that you got them all correctly. Inscribed angle, minor arc, all of those. Okay, and let me know if you guys have questions on those. But I think you're doing pretty good. Okay, so over here, find the area and the circumference. Well, first of all, our radius is equal to 8 because our diameter is 16. And our diameter is equal to 16. So first thing, I'm just going to find our circumference first. So circumference is equal to 2 times pi times your radius, which is 8. Remember, you guys, we're going to use 3.14 for pi because on Canvas, it doesn't have a pi symbol. So just use 3.14 for pi. This is what you want to use, and then round accordingly. So we're going to do 2 times pi times 8, which is going to be 16 pi. And we're going to multiply that 16 times 3.14. And we will get 50.24. All right, next up, we're going to find the area. And your area is going to be equal to pi times your radius, which is 8 squared. That would be 64 pi. And when you multiply 64 times 3.14, you will get 200.96. Oakley doke. This one is a tricky one. It says a bicycle has wheels of 28 centimeters in diameter, meaning that our radius would be 14 and 14. Find the approximate distance that the bicycle moves forward during 20 revolutions. So you want to think, how many times does this bicycle wheel rotate 20 times? You're going to take your circumference and multiply it by 20. The distance around 20 times, 20 rotations. Woo! Okay, so we are finding our circumference, which is 2 times pi times our radius, which is 14. So 28 pi, which is 28 times 3.14. And we will get 87.92. Okay, now we've got to multiply that 87.92 times 20. And we'll get 1,758.4 centimeters. Okie doke. Find the area of a circle with the circumference of 36 pi. Okay, so the circumference, we're going to take 36 pi and set it equal to our formula for circumference. 36 pi equals 2 pi r. I'm going to divide by 2 pi to start, and our pi's will cancel out, and 36 divided by 2 is 18. So I'll get my radius of 18. Now to find my area, I'm going to take that radius, multiply it by pi, but first I need to square it. So 18 squared is going to be 324, and then times 3.14, which is pi, and we will get 1,017.36 centimeters squared. Okay, so let's move along to number 16 here. It says, find the circumference of a circle with an area of 706 706.86. So we're going to do 706.86 and set it equal to pi, pi r squared. So first things first, we're going to divide by 3.14. And we're going to get approximately 225, and that equals our radius squared. Then we have got to take the square root and the square root, and we will get our radius is equal to 15. That's our radius. Now we need to find the circumference. So circumference is equal to 2 pi r, which r is 15. So we have 30 times 3.14, right? We got the 30 by doing 2 times pi, and we get approximately 94.2. Okay, find each arc measure. Remember that that's degrees. So CB. Okay, well, first of all, we see that there's this 90-degree angle. So to find CB, we are going to do 90 and subtract the 53 that they give us, and we will get 37. So this one is 37. I'm just going to write it along as I go. Next up is AB. All right, well, to find AB, I look and see, hey, here's a diameter, and I have half of this circle right here. So what I'm going to do is I'm going to do 180 minus 79 minus that 37 I just found. And when I do that, I will get 64. So 64 is right here. Okay, next up is ED. So what I'm going to do is I'm going to add all of these parts, 79, 64, 37, and 53. So 79 plus 64 plus 37 plus 53. And that is going to give me, hold on, give me a second. I thought I wrote it down, but I did not. 64 plus 233. So I'm going to take 360, a complete circle, and subtract 233, and I will get 127. Okay, next up is from E to D to B. Well, part of that is a semicircle all the way right here. And now I just have to add this distance, 37. And so plus 37 I'll get 217. Okay, so then what I'm going to do next is take 360, the entire circle, and subtract 217, and I will get goodness, guys, I was doing this one wrong. Ignore what I just said about EBD. I went the wrong way. I went from E to D to B. You're supposed to go from E to B to D. So I'm just going to add all of those numbers, which will give me 233. How I got that was adding 79 plus 64 plus 37 plus 53. And I got 233. Okay, so next up, it says solve for x and for FDB. So from F to D to B, I'm going to be solving for this portion of the circle. So first of all, I see that these are 90-degree angles. Vertical angles. So this would be 45 degrees. Well, to solve for x first, I'm going to add these two together. And then when I solve for FDB, we'll get to that in a second. But first, to solve for x, I'm going to do 6x plus 33 plus 45 equals 180. So 6x plus 78 equals 180. And I'll subtract and I'll get 6x equals 102 and x equals 17. Okay, and then it says to solve for the measure, again in degrees, of FDB. Well, I'm going to go ahead and I'm going to plug my x in here. So 6 times 17 plus 33 will give me the degrees here. That equals 6 times 17. 135. So now for FDB, I am going to do 135 plus 45 plus 28, and I will get 188. Okay, so now they're asking for arc length, which is like the pizza crust that we've talked about. So we're going to take the total measure of degrees, 110. We're going to multiply it by our circumference right here, which is going to be 2 times pi times 18. And we're going to divide it by 360. All right, when we multiply these across, we get 12,043.44. We'll divide it by 360, and we will get 34.54 centimeters. All right, that is the length of that pizza crust. Okay, so it says if the circle below has a radius of 15 centimeters, so 15 for the radius, solve for the length of U from U to X to W. So all the way over here, we want that arc length. Okay, so we've got to figure some things out first. Well, we know that this bit is 26, so this is a semicircle. We're going to do 180 minus 26, and that will give us 154. So now I'm going to add these up together. 154 plus 26 plus 90. 154 plus 26 plus 90, and I will get 270. Okay, I'm going to take that 270, the total measure there, and go ahead and find the length. So 270 times 2 times pi times 15 over 360. When I multiply my top bit up here, I get 25434 over 360, which when I divide, I'll get 70.65. Okay, moving along to page number 2. Solve for the measure of AT, arc AT, so that would be right here. And they want us to solve for the measure of TEA, this angle right here. Well, the key part of this is that this is an isosceles triangle. So if these two legs are congruent, then these two arcs would be congruent, right? Based on the rules of circles. So this would be 130. Okay, and then to find this arc, we would add these together, 130 plus 130, and we would get 260. We would subtract it from the whole circle, 360, and we would end up with 100. So we would know that this arc, AT, is 100 degrees. But it asks us to solve for this angle, which is an inscribed angle, which means that it's half as much as the arc. So we would do 100 divided by 2, and we would get that angle to be 50 degrees. Okay, solve for the value of x. Well, we just did one like this on the SPA, right? So we know that all of our radii are the same, meaning that this would be 10, that piece right there. This radius is x, which is also our hypotenuse. And remember that this would bisect that chord, so this becomes 9. And it's a right triangle where we know two sides, so we use our favorite, the Pythagorean theorem. 100 plus 81 equals x squared. 181 equals x squared. We take the square root and we get 13.45. Pretty exciting stuff. Okay, next up, the measure of MHT. So MHT, which is that angle right there, and MAT, this angle right here. If you notice, they're intercepting the same arc, so that means that they would be congruent to each other. We will set them equal. For x minus 10 equals x plus 20. We set them equal because they're intercepting the same arc and are therefore equal to each other. We end up with 3x equals 30 and x equals 10. All right, well, the end is asking me to solve for MT. So MT is right here. I can plug this 10 into either of these. I'm going to plug it in to angle MAT just because it's a little bit less complicated than the other expression. So 10 plus 20 equals 30. Well, we now know that this angle is 30. Because it's an inscribed angle, it's half as much as the arc. So to get arc MT, we have to multiply 2 by 30, and we'll get 60 degrees. Okay, so next up, we see this angle. And I don't know if you guys see, but it intersects the diameter or a semicircle, which makes it 90 degrees. And then hopefully you also see that right here a triangle is created. So I'm going to go ahead and figure out this angle too, because I think it's going to be pretty useful. So I'll do 180 minus 90 minus 59, and I will get 31. So I know that angle is 31. Well, the next thing it's asking for me for is ML. So I see that the inscribed angle is 59. It's intersecting this arc. So to find arc ML, I'm going to do 2 times 59. I'll get 118 for this arc right here. Next up, it says MJ. Well, it's kind of nice that I already figured out that the inscribed angle that bisects it is 31. So MJ is going to be equal to 2 times 31, which is going to be 62. Okay, next up is JLK, angle JLK, this angle. Well, we see the arc that it intercepts, so we're going to do angle JLK equals half of 134 divided by 2, and we will get 67 degrees. Next up is angle JLM. Well, we already found that out when we subtracted for the triangle, so we know that's 31 degrees. Okie doke. Last up on this page is solving for x. Okay, it's an inscribed angle. It's always half as much as the arc that it intercepts. So we're going to double this. 2 times 9x minus 25 equals 94. I got to double the inscribed angle to set it equal to the arc. We're going to divide by 2 and divide by 2. We'll get 9x minus 25 equals 47. We'll add 25 to both sides and get 9x equals 72. And divide by 9 and divide by 9 and get x equals 8. Okay. Next up here, we have angle RAI. So this angle right here, RAI, it equals 2x minus 9. And arc IN, this arc right here, equals 58. And arc RN, this arc right here, equals 44. It wants us, It wants us to solve for x. So this is its intercepted arc. I'm going to add those two together. And 58 plus 44 equals 102. So I know that this entire arc right here is equal to 102, right? These two added together. So now I'm going to do 2 times 2x minus 9 equals 102. I'll divide by 2 and divide by 2 and get 2x minus 9 equals 51. All right, I'll add 9 to both sides and get 2x equals 60. And divide by 2 and get x equals 30. Okay, next up, number 27, probably the trickiest one on the study guide. Hopefully you guys see that, hey, here's a radii and here's a radii. This is 12, so this has to be 12. This is tangent to a radii, which means it has to be perpendicular. Lo and behold, we have a right triangle. So we are going to use the Pythagorean theorem to solve for x. We're going to do 12 squared plus 16 squared equals x plus 12 squared. Okay, 12 squared is 144. 16 squared is 256. And we've got to square this. Remember, we're not distributing the 2. What we're doing is something like this. X and 12, x and 12. This is x squared, 12x, 12x, and 144. All I did was x times x to get this one, 12 times x to get 12x, 12 times 12 to get 144. I will combine my like terms. I'll get x squared plus 24x plus 144. I'm going to simplify a bit. I'll get 400 equals x squared plus 24x plus 144. And I want it to be equal to 0 because it looks like I'm going to have to factor. I'll get x squared plus 24x minus 256. Okay, there is no GCF here, so I'm going to just straight up make my x factor. Get negative 256, right? Bring down my middle brother, 24. What multiplies to negative 256 but adds to a positive 24? That would be a negative 8 and 32. So I have x minus 8 and x plus 32. I need to solve for them, right? Because I need to know what x equals. So x minus 8 equals 0, and x plus 32 equals 0. I'll add 8 and get x equals 8. And I'll subtract 32 and subtract 32 and get x equals negative 32. Well, we're talking about a distance here, so we can't use the negative, right? We will just use 8, the positive version. Okay, next up, they are originating from the same point and tangent to the same circle. Therefore, they will be equal. So to solve for x, we will set them equal. 10x minus 19 equals 4x plus 23. I'll simplify a bit and get 6x equals 42 and x equals 7. Okay, remember, if they're tangent to the same circle, then they are congruent. So if this piece is 6, then this piece is 6. And if this piece is 28, then this piece is 28. And I need to solve for this piece, so I'm going to take 27 and subtract the 6 and get 21, which if this piece is 21, then this piece is 21. Okay, I'm going to add these together, 6 and 28. I'll get 34. And I'll add 21 and 28 together, get 49. So now when I add 27 plus 34 plus 49, I get 110 for the perimeter. Next up, solve for the area of the shaded sector below, given the radius is 21. Okay, so I'm going to take my arc measure, 120. I'm going to multiply it by the area of a circle, so pi times my radius, which is 21 squared, and it is all divided by 360. So 21, I'll get 120 pi times, well, 21 squared is 441, and I'll divide by 360. When I plug this into a calculator, I get 461.81. And that's it. That's your study guide. Not too bad. All right, guys, let me know if you have questions, and I will see you soon. Bye.